Good afternoon, everyone, and thank you for joining us for our webinar, Unified Technology Architectures through Cisco UCS. Presenting today is Joe Piparato of Cisco. Joe is a 14-and-a-half-year Cisco veteran and is a consulting systems engineer focused on Cisco's data center solutions, including the Unified Computing System, Nexus switches, storage solutions, cloud technologies, and data center automation and orchestration solutions. We're pleased to have Joe join us today. So without further ado, I'd like to turn the presentation over to him and get things started. Joe.
Appreciate that. Thanks, Jake, and thanks everybody for attending today. Getting a healthy dose of snowfall here in the Albany area, so the WebEx option for these types of events works out quite well. So without further ado, let's jump right into it. So we're going to spend some time here on the Unified Computing System, or UCS. For those that have some familiarity with it, I've also baked in some information on our latest announcements. So on September 4th, we made several major announcements, some new products and enhancements to existing products, so we'll talk about those as well. But just a quick quote from the man himself, and it should be no surprise to folks that have some exposure to Cisco's data center solutions. Obviously, it's a top priority for us, certainly one of our top 5 corporate priorities. It's a massive area of R&D for us, and the results of that R&D or those R&D efforts are really what you see come to fruition in things like UCS and Nexus and our MDS product line. So just know that it certainly has been and will continue to be a major area of innovation for us. So it's also no surprise that there are things in the data center that we don't touch, right? It wasn't until just over 5 years ago that we became a server company, and we've had a long, healthy track record of success since then. But there are certainly things we don't offer today, right? We don't offer our own database software. We don't offer healthcare software. We don't offer our own hypervisor or SAN solutions outside of one that I'll talk about, and then solid-state storage solutions, right? We don't have a general SAN solution, if you will. So where we don't have a solution, we partner with the best, right? And this is obviously just a subset of those companies. But beyond just partnering with them, we produce validated designs, right? Public-facing validated documentation that you can use, whether you're trying to right-size a VDI deployment, you want to deploy Exchange on UCS, you want to work with any of the storage vendors that you see here or any of these hypervisor vendors. Right? The results of these relationships are really some tremendous documentation that you can leverage for your own infrastructures. Right? So what is it about UCS? Right? Why does it matter? Why has it become, quite recently announced, why has it become the #1 solution for new blade sales in North America? And it's really the list of items that you see here, and we're going to spend some time talking about most of these in this presentation. But there's one thing that gets more attention than anything else, actually 2 in this particular silo. One of them is UCS Manager. So many years ago when we set out to create UCS, our customers were telling us and telling the industry that some things have to change in the data center space from a server perspective. Architecture, right? So if you do what you've always done, you'll get what you've always gotten. Customers that had a one-time consolidation event in their environment, generally we're still connecting things at gigabit Ethernet speeds, thus the architecture or the number of cables, the connectivity, even though they may have reduced their servers by 60, 70, 80%, the amount of connections in the data center hadn't changed. So it's the same number of connections, just split across a smaller number of servers. That's a design or deployment methodology that really doesn't scale. Right? At some point, my customers got to a point in their data centers where they want to add server number or server X, and guess what? They don't have enough Ethernet ports and potentially SAN ports northbound to support that server. So they had to invest in additional switches, both on the LAN and the fabric side. Now, Cisco doesn't mind that. It just so happens we are a switch and a SAN fabric company, but there's still a better way to architect things prior to UCS coming into existence, right? There had to be a better way, And UCS brings that to the table with Unified Fabric, and we'll certainly spend some time on that and what that means for you. But also UCS Manager, so centralized management that was in existence outside of UCS, and I would argue to this day, the type of centralized management solutions that are out there are definitely lacking and simply cannot hold up to what we can do with UCS Manager, and quite frankly, what we've been able to do with UCS Manager since day one. Later on in the presentation, we'll spend some time on service profiles, firmware management, the operational simplicity inside of UCS Manager that makes a tremendous difference. So the one thing I like on this slide, industry standard server components. Right? There's no magic, there's no smoke and mirrors under the hood. It's Intel processors, Samsung and Micron memory, standard hard drives. It's what we do with those components, right? It's how they're packaged, it's how they're managed, it's how they're controlled, it's how they're deployed. That is really where the differences lie, right? It's the performance, the bandwidth that we're capable of delivering to a chassis and to a server, right? So it's everything we surround those industry standard components with that makes all the difference in the world. So the name itself, let's talk about that for a little bit, because the name obviously is pretty simple in some regards, yet very powerful, right? It's a unified computing system. It's not just about the blades or rack mounts, right? We're both a blade and a rack mount server company. We're not tied to one form factor or the other. But obviously the compute piece is easy, right? Of course, it's a server solution. But what about this unified aspect of it, right? Well, that's where we bring together, as you might guess, we're bringing together your network connectivity, right? So your northbound connectivity from your server deployment, right? We unify that connectivity in a pair of devices we call fabric interconnects. So your northbound connectivity is accounted for. Your SAN connectivity is also accounted for. So in this same pair of fabric interconnects, this redundant server access layer, we have not just your compute connectivity, but also your LAN and SAN connectivity. And we also have technologies that we can embed in the solution that allow for hypervisor awareness, hypervisor visibility and control, right? So the culmination, right, where all those things come together is where UCS exists. And it's important to note, unlike most of our competitive offerings, we include centralized management by default, day one, out of the gate. It's included redundantly with a blade deployment. It happens to be an option. You can add it on to a rack mount deployment, and we do see a lot of interest in that area. Generally, a customer will draw a line in the sand and say, when I get past 10 rack mount servers, yeah, it would be nice to manage them centrally. And we actually have a few options for that today. And energy efficiency, not to be outdone by the other highlighted items here in blue, but because we got to define and create UCS from the ground up, we got to create the industry's most efficient server solution for the data center, right? So it really comes back to doing more with less. I have fewer components, I have fewer cables required, again, without sacrificing performance, mind you, right? But I have fewer components, fewer connections, fewer adapters per server, fewer adapters per chassis, right? That alone accounts for a tremendous savings in power and cooling costs when it comes to operating servers in your data center, okay? Then we'll talk about a power calculator a little bit later on. So not my wording, but I kind of like it. You know, they call it an accidental architecture. Coming back to do what you've always done, you'll get what you've always gotten. What deployments have looked like outside of UCS is every time I deploy a chassis, I have management modules, I have Ethernet modules, I have SAN modules. It yields nothing more than a complex architecture, right? Lots of modules, lots of cables, lots of touch points, lots of failure points, lots of firmware management points, right? It's not an architecture per se, right? It's a deployment, but it's not something meant to scale or good for a long-term data center strategy. So what did we do to pare things down as much as possible? So again, we embed the management. There's no separate management components required. It's built into the server fabric, okay? And it runs redundantly, of course. Unified fabric. So by nature, when you unify the fabrics, Again, we have Ethernet and SAN connectivity all centrally managed and controlled. You no longer have to have separate Ethernet and storage modules in each and every chassis that you deploy in your environment, whether that's IP-based storage, fiber channel over Ethernet. Okay. We bring along with it, again, some features for hypervisor optimization. So it's not just for hypervisors, of course. Lots of UCS deployments are running bare metal workloads, maybe 100% bare metal, but at least some combination of hypervisor and bare metal deployments. So again, when you remove all those unnecessary components, right, the separate modules for LAN and SAN connectivity, management modules, and you can boil all that down to a very, very simplified solution. Right? We allow our customers to deploy the most efficient from a power and cooling perspective, but I would also argue the best solution from a bandwidth perspective, and we'll talk about some connectivity options here in just a little bit. Okay. So this would be a rather large install. If a customer came to us and said, this is what I want, we wouldn't say no to that. We would like that very much. The reality is most customers are getting into UCS. Again, we do have some that will come to us and do a wholesale replacement, regardless of what the incumbent vendor is. They'll maybe every 3, 4, 5 years they have a server refresh, and we do see wholesale replacements. But the typical customer is investigating and implementing and investing in UCS for a particular application, whether that's VDI, maybe it's an application expansion, maybe they're rolling out Cisco Unified Communications and want to put it on UCS. So our general deployment for our initial customer, what they would usually look at on average, would be a pair of these 2 devices up top, right under where it says embedded management. That's a pair of fabric interconnects. That is your redundant server access layer, again, that you will get with your very first chassis. And those 2 devices, that pair of redundant devices, can scale up to 20 chassis and 160 physical servers. Right? That can be all blade, that could be all rack mount, or any combination thereof to support the workloads in your environment. Okay, what you'll notice in those devices, not only is UCS Manager included, it's redundant and it runs on those 2 devices. We don't have separate licensing, we don't charge for UCS Manager, it's simply part of the offering. But it's those 2 devices responsible for your connectivity to 1 or more SAN fabrics, responsible for connectivity to your core distribution layer, and if you have a separate management network, certainly we can tap into that as well. But what you'll notice in the chassis themselves is they only connect to the fabric interconnects, right? And it is nothing less than 10 gig. There is no such thing as gigabit Ethernet southbound from those fabric interconnects. So it's some combination of 10 gig connectivity from every chassis, redundantly connected, of course, into those fabric interconnects. Okay. And again, I started saying, I probably didn't finish that thought, but from an average customer, it's a pair of these fabric interconnects. Our average customer, even though they may only start with 4 blades, they actually prefer to split that from a redundancy perspective across multiple chassis. So typically see 2 fabric interconnects, 2 chassis, and 4 to 8 blades for an initial customer investment. And again, after that, you're not adding anything else from a server access layer perspective other than physical connectivity into a new chassis. Okay, and we'll talk about the key aspects here along the bottom: expanded memory or extended memory, virtualized adapters, and service profiles, of course. So just to give you a more simplified view of the building blocks of UCS, at the very top, again, we're going to offer you and include UCS Manager, right? Free centralized manager, full-featured centralized manager, more specifically, that runs embedded on these fabric interconnects. Those fabric interconnects are either a 48 or 96 port device, supporting gig, 10 gig, fiber channel, and fiber channel over Ethernet. They connect in a very, very simple way into each chassis in your environment. So I mentioned there's no Ethernet switching, fiber channel switching in a chassis. What you actually have inside the chassis is what we call an I/O module or a fabric extender. Okay. That is a passive component whose only job is to function as bandwidth aggregator, and it provides in-band management. Okay, so it's not switching packets. It's simply a bandwidth aggregator for that northbound connectivity. Because we don't have switch modules inside that chassis, we can provide to our customers the industry's best performing server solution. There are several studies out there that compare a standard deployment, if you will, to those of each of our top 3 competitors, and we have the best performing solution, lowest latency solution for blade-to-blade communication in a domain. And a domain equals a pair of those fabric interconnects and up to 20 chassis and 160 blades that are part of that same deployment. So it's designed from the ground up to be a high-performing, low-latency solution. Of course, inside that chassis wouldn't be really a computing solution per se without some sort of compute technology. So inside that chassis, you're going to put some combination of half-width and full-width blades. Generally, the half-width are dual socket, and the full-width are quad socket. Rule and talk about some of the workhorse platforms that we have that have come out recently. But you're allowed any combination of 8 half-width blades, 4 full-width blades, or any physically allowed combination thereof. We don't have any restriction that says if you put a full-width blade in slots 1 and 2 that you have to use a full-width in slots 3 and 4. Simply no requirements in that regard. And of course, on the blade itself, I mentioned again it's industry standard components. Intel processors, Samsung and Micron memory, Cisco converged network adapters, or third-party CNAs. Right, that's your mezzanine card. All right, and industry standard hard drives as well. From a data center solution perspective, in Cisco's eyes, nothing is data center class unless it can deliver a very specific level of resiliency and redundancy. And we've certainly built that into UCS. So every aspect of the solution, both the fabric interconnect power supplies, the fabric interconnect fans, power supplies and fans and I/O modules on the chassis, everything you see here, this is a front view of course, and everything you see here supports hot swap or online insert and removal. So to maintain the solution on the fly, whether you're replacing a power supply, replacing a fan, maybe you're doing an upgrade of an I/O module to the next gen I/O module, right? The chassis itself is passive, so there's no chassis swap out required to support that next gen component. But it's important to note from an operational perspective that we will allow you to hot swap or do online insert removal of all components inside that UCS solution. Chassis itself, very, very simple, just 6 rack units tall, 32 inches deep. Again, supporting up to 8 servers or 8 half-width blades and just 6 RU. Some interesting features here around power. So again, of course, the power is fully redundant. Most customers run at least N+1 power. You can also do what they call grid redundancy or N+N redundancy, whereby you're driving multiple circuits into each set of 2 power supplies. But we also have a feature called power capping. I've documented and certainly would like to send it out after this presentation to everyone that attended. But I put together, right now it's 4 features that I have chosen to highlight related to UCS Manager. And they're features above and beyond that which we tend to cover in this type of session. Things like power capping, whereby on a per chassis basis and even a per blade basis, I can guarantee a certain amount of power to specific servers in my environment in the event of a power situation. And so if I lose half the power to my chassis for some event that occurred in the data center, I want to make sure blades 1 and 2 are guaranteed X amount of power. Maybe they're running my business critical applications. I can provide guarantees to those blades, to those applications in a UCS deployment, and I can let other blades share the remainder of the power that's available, for example. So just simple but very powerful features like that are all over inside of UCS Manager, and we can certainly touch on a few more of those as well. This is a view of right now the most recent and the largest from a bandwidth perspective I/O module that we offer. So what you see here is 8 Physical ports, that would be for northbound connectivity. Excuse me. Right, so this is 8 10 gig connections. Sorry, had to grab a drink there. 8 10 gig connections on each side of the chassis. So you could have up to 160 gig of bandwidth northbound from a chassis. Most customers start with 40 gig. That tends to be a pretty healthy increase above and beyond what they're running in a non-Cisco solution. But I'll show you the 4 options that are available from a bandwidth perspective. So I mentioned the 8 northbound. You can see the 8 physical ports here. These support SFP or SFP plus transceivers. What you don't see are the 32 10 gig internal connections. So each one of these, again, you would have a pair per chassis, is going to drive 32 10 gig connections towards your blades. Right? So we can actually, in an 8-blade system, we can feed dual 40 gig connections per each side of the blade. So the A side would have 40 gig, and the B side would have 40 gig. I can guarantee you that no customer has ever complained about bandwidth availability in a UCS deployment. Right? We've addressed that since day one. The fabric interconnects themselves, here are the absolute latest models. So the 6248 and the 6296. As you might guess, both 48 and 96 port flavors. And the UP designator there stands for Unified Port. And what that's all about is really the flexibility of that solution. It allows the device to support simultaneously gig connectivity, 10 gig connectivity, IP-based storage protocols, fiber channel, and fiber channel over Ethernet. So in a lot of environments, the SAN is coming in, or the SAN fabric is being fed into the fabric interconnects via fiber channel. We're starting to see certainly a rapid increase in fiber channel over Ethernet deployment. But certainly to your chassis, it's going to be 10 gig and optionally fiber channel over Ethernet. And then northbound is going to be gig or 10 gig Ethernet. So this unified port functionality allows a chassis, and we also support this in our Nexus product line, but it allows that device, that fabric interconnect, to support all those connectivity speeds and protocols simultaneously. There's also an expansion module. So the 48 port version actually comes with 32 ports out of the box. You can add a 16 port expansion module to get yourself to the full 48 ports. The 96 port version, that's the top end, that's the max number of interfaces it will support. Out of the box, it has 48 ports, and there are 3 expansion slots, and you can, of course, install one of these expansion modules in each one of those slots to get you to 96 total unified ports on that platform. Okay. So your connectivity options. There are actually 4 different options, and it's really on a chassis-by-chassis basis. You may have a chassis full of, let's say, user services. Right? So it's running AD, DNS, DHCP, print server. We probably don't need 160 gig coming out of that chassis, so maybe dual 10 gig connections will do it. The one thing to keep in mind here again is this is an active-active topology. Right? So when I feed dual 10 gig connections, it's not a typical spanning tree environment where you would have 10 gig active or a forwarding link and 10 gig blocking, right, or a non-forwarding link. Both links are capable of forwarding traffic simultaneously. Because of that, a lot of customers actually start with the second option here. This seems to be kind of the default approach, is dual 10 gig connections per side. So coming out of a chassis, regardless of how many blades I have installed in that chassis, I'm going to have 40 gig of total bandwidth northbound that can be used for communication. And again, that seems to be the most popular starting point. I do see a number of these deployments with 4 connections per side or 80 gig per chassis, and ramping it all the way up using that 2208 fabric extender. I can deploy 8 10 gig connections per side or 160 gig of bandwidth per chassis. And your deployment could look exactly like this. Again, it's on a chassis by chassis basis. We do have a solution now called UCS Performance Manager. At some point, we might see this built into UCS Manager. But today it runs as a separate VM, again, recently released. But I used to get a lot of requests from customers, certainly in non-Cisco environments. How do I look at the amount of bandwidth my blade is using? How do I look at the amount of bandwidth coming out of a chassis? Am I starved for bandwidth? Do I have too much? Is it just right? How much bandwidth is coming out of my server access layer? So this application called UCS Performance Manager gives us those capabilities. A fantastic option for capacity planning, for example. Maybe I have 6 blades installed today with 2 10 gig connections per side. How much headroom do I have on that current established bandwidth? Do I have enough to install and adequately run those 2 additional blades that I might be installing for a hypervisor, for example? So great option, and then something to keep in mind from a capacity planning perspective. So September 4th is being referred to as our second most important UCS announcement ever. The first most important, of course, is the day we announced it. But on September 4th, we announced a number of new solutions in the UCS family. And one of them is what you see here, UCS Mini. UCS Mini really encompasses everything we've already spoken about, right? Fabric Interconnects, UCS Manager, redundant connectivity, and redundant management, of course. But we take a slightly different approach, and it's geared again at small, medium business, branch sites, right? Today, it's any location that requires 8 blades or fewer. In the future, we're going to allow customers to add a second chassis. But this is what it looks like, right? The chassis itself is no different. But what you'll notice that's different is on the right-hand side here. That's no longer a standard I/O module. That is the Fabric Interconnect. It's the functionality of that 6248 or 6296 created as a module. And of course, you have 2 of those installed in a chassis. So now in that same 6 rack units, not only do I get up to 8 half-width blades, but I also get UCS Manager and Unified Fabric support, connectivity directly into the chassis. Okay. There's actually a 40 gig link, the bottommost connection that's not the RJ45 there. That's actually a 40 gig connection. In the not too distant future, we will be able to support a second chassis. That's called a scalability port. So we'll be able to support a second chassis under UCS Mini that can hang off of this particular or primary chassis. That second chassis only needs a standard set of those I/O modules, either the 4-port or the 8-port version. Okay, and then the other ports here, those other 4 interfaces support both gig and 10 gig for northbound and direct SAN connectivity. So what it could actually look like today, again, it's 1 chassis, up to 8 blades, but you can actually use those physical interfaces, again, to connect rack mount servers. So we are seeing, I would say, a pretty healthy uptick in hybrid environments from a server form factor perspective. We're starting to see a lot of environments that use blades where it makes sense for them, and they use rack mount servers where it makes sense. So if they need a lot more local storage on a per server basis, rack mounts are the obvious choice there. Okay. But this is exactly what a deployment could look like today. SAN connectivity, again, this can be direct or it can be via intermediary switches. Right? So whether we're talking IP-based storage protocols, fiber channel over Ethernet, we either already have the capability day one to support direct or indirect connectivity, or we'll surely be supporting connectivity direct or indirect. A little bit on the blades themselves, and things get pretty interesting here. And even though we've announced the M4 family, so a lot of them were announced on September 4th as well, the M3 is still a very relevant product line and will continue to be so at least through 2016 is what our business unit has committed to. Right? And that doesn't mean it'll be supported until then. That means it'll be for sale at least until the end of 2016, and of course supported for many, many years beyond that. But one thing that we did on the M3 product line was the ability to run everything off of a pair of SD cards, and our name for that is Flex Flash or Flexible Flash technology. So the M3 product line was the first to introduce the dual SD card option. We can, of course, support that on the rack mount as well. And I'll talk about the VIC 1280 here. That stands for Virtual Interface Card. But let's take a look at some of the specs here. I'm going to take you right to this slide. One thing you'll notice here, and this comes up in a lot of competitive situations, really across the board. So the second blade over here, the B200M3, absolute versatile workhorse in the M3 product line. And we of course have a blade in the M4. So M3 supports Ivy Bridge processors, E5 2600 and 2600 V2. Anything that says M4 supports Haswell processor line from Intel. But what you'll see here on both the B200M3 and the B200M4 is the fourth item down, DIMMs. Architecting a blade to support the max number of DIMMs is or can be a tricky proposition. Our competitors in this same form factor support 16 DIMM slots. We have 50% greater capacity above and beyond what our competition can offer. So in that same half-width form factor on a B200M3 or B200M4, we provide 24 DIMM slots. Okay. When it comes back to the adage of doing more with less, we allow customers to scale memory higher with lower cost DIMMs. So you're not forced into using 32 gig DIMMs, for example, to get to certain memory capacities. We can scale quite nicely with 16 gig DIMMs. In fact, pretty much every request I see for a UCS config in this day and age, 256 gigs seems to be the new entry-level amount of memory, if you will. I get a lot of requests, certainly for 256, 384, and starting to see an uptick in 512 and 768. So on that little half-width blade, again, to get to 768, we'd of course have to use 32 gig DIMMs, but we can get you to 384 gig via the use of 16 gig DIMMs. So the potential to save quite a bit of money on memory alone when you consider the use of 32 gig DIMMs on a competitive solution that only gives you 16 DIMM slots. Again, we can share these specs with you. I didn't want to go through each and every spec, just wanted to point out some of the differentiators here. So the M4 family, again, all things being equal, it's still 24 DIMM slots, up to 80 gig of I/O, right? Supports Flex Flash, of course. It does have an option for a modular LOM slot for another virtual network interface card, and of course dual socket. So it supports the E5 2600 V3, and with up to 18 cores per socket, provided you're not trying to tackle a SQL or other per core licensing scheme. But again, the power of these blades, right? We support the full range of processors. Something else I'd like to point out from a competitive perspective, specifically with one of our competitors. One of our competitors, it's HP. In their comparable blade, there are actually 5 processors in the Haswell product line. Because of the inefficiencies in their power and cooling design, they can actually only support 12 of those 16 DIMM slots. So we have no such restriction, right? We designed this from the ground up to be extremely power and cooling efficient. So we have no such limitation with regard to that Haswell or any other processor line. So for certain processor specs, the comparable HP blade, you'd be restricted to 12 DIMM slots. We would have double that capacity in this particular form factor. Also in the M4 line, so this is, even though this is a B2 product number, right, it is a full width blade. This one's actually geared at extreme memory densities. So it's dual socket, full width dual socket, up to 30 cores, split between those 2 sockets, and 48 DIMM slots. Right? So extremely healthy memory densities. What's interesting about this platform, so the servers that you see here is actually 3 of the same exact component. In the bottom right-hand corner, we pull off what we call a scalability terminator, which is what you see, that black and silver component in the upper left-hand corner. We replace that with a scalability connector, and we're actually stacking 2 of the B260 M4s to create a single B460 M4, which becomes a 4-socket, right? So up to 60 cores, 96 DIMM solution. So interesting in its ability to morph from dual socket 48 DIMMs to 4-socket 96 DIMMs, but an absolute versatile workhorse in that UCS product family. Right. And Not to be left out, of course, again, we have a healthy percentage of our server business is the rack mount space. I'm generally seeing a lot more interest in blades. It seems to be a form factor that customers are appreciating from a density perspective, right? So in 6 rack units, I can get 8 servers. In the blade world. In those same 6 rack units in the rack mount world, I can only get 6 servers. So even if you factor in the 2 fabric interconnects at a rack unit per, when you add that second chassis, you're still at a capacity advantage with the blade form factor. But when the amount of local storage required or number of drives, more specifically, the number of drives and or the number of PCIe adapters exceed that which are available in the blade form factor, that's where we really see customers looking towards the rack mount solution. And we'll take a quick look here at some of the specs. Again, the M2 would be the prior generation. We really want to focus on the M3 for Ivy Bridge and the M4 for Haswell product lines. If there's any questions later on, if you have any questions on the specs, we have some great public-facing documentation, of course, that we can send your way that'll have an exact breakdown of each and every model, and it'll have all these specs and then some. But one thing to point out would be the LAN motherboard. I did not point this out on the blade, but everything in M3 and later, and even in the rack mount world, some of the M2s, but you're going to have a certain amount of bandwidth included. It's going to be at least today dual 10 gig connections, and that's for rack mount. In the blade world, we're going to default to dual 20 gig connections per blade, and we can, of course, scale that up to dual 40 gig connections. One interesting change on this platform, so the prior gen, the C220M3, had 16 DIMM slots without changing that form factor, right? So it's a C220M4, still 1 rack unit, but we're now up to 24 DIMM slots in I'll call it our entry level, or really our smallest, right? It's also a versatile platform that can meet a variety of workloads with that Haswell processor line. But yeah, this particular platform, again, up to 24 DIMM slots now, and up to 8 small form factor hard drives or 4 of the large form factor drives. Wrapping up a little bit, identical from a processor and memory support perspective, but this is the big brother to the C220, the C240. This would get you, of course, additional local storage, so up to 24 small form factor drives, and additional PCIe slots, so that doubles on this platform. And, of course, the quad socket. The vast majority of what I work on and what I see from a configuration perspective is for dual socket configurations, but there are a number of applications that will thrive in the quad socket space. And again, for high-end database workloads, certainly a classic example, depending on the type of database and what kind of performance that you need, something like this that gives you 96 DIMM slots and up to 60 cores of processing power is certainly a good option. So this is actually a brand new addition to the family. It does fall into the C series of the rack mount space. This is our, what we would call our tier 3 or archive storage solution, right? It's great for unstructured data storage. We've seen several opportunities for this actually, for that exact function, for archive function. And today, with the ability to support up to 60 drives in 4 rack units, this will support up to 240 terabytes of local storage. Down the road, we will support 6 terabyte drives, and that, of course, will get you up to 360 terabytes in that same 4U. So we do call this, the product number is a 3160. It's the high-density modular storage offering. We do have a high-density modular compute solution coming out. This solution was discussed on the 4th. It will be available early 2015, but think of it as the inverse of this, right? It's minimizing the amount of storage locally, but maximizing the number of compute nodes. So we now have both a high-density modular storage, and we will shortly have a high-density modular compute solution. There will be a second version of this early next year called a 3260. That will actually double the compute node. So today it's a single compute node. In the 3260, we'll have a second compute node option, and that version will also be able to be managed by UCS Manager. When it comes to hypervisor or addressing hypervisor or addressing VMs more specifically, and allowing for hypervisor scalability with features like hypervisor pass-through, we have our line of virtual interface cards. So we have a VIC 1240 for 40 gig of bandwidth. The VIC 1280 delivers 80 gig of bandwidth. We now have a flavor of those, the 1340 and 1380, that delivers both VXLAN support as well as low latency communication. But again, the bandwidths are still either 40 or 80 gig, and that's on a per server basis. So I've never heard from a customer, gee, I wish I had more bandwidth in my UCS deployment. Right? We've addressed that from day one, and we have tremendous bandwidth scalability that, again, you can increase that. You could start with a 40 gig adapter, and a year from now, if you wanted to double that throughput to 80, you do have that option on a per blade basis. But this particular adapter is one that supports virtual machine fabric extension. So we have the concept of a physical fabric extender installed in a chassis. This VMFX is virtual fabric extension. So this would allow you to associate virtual interfaces with each VM in your environment. That would allow for hypervisor pass-through. So it's going to offload the VM-to-VM traffic processing from the hypervisor, freeing that hypervisor up, generally for more scalability and better performance. Okay. We spoke about the 80 gig host connectivity. So kind of tying everything together, you know, this slide strictly talks about the VM as the center of the universe here, but UCS is, of course, also for bare metal workloads as well. But when it comes to VM scalability, when you look at the bandwidth, VMFX, the hypervisor bypass or hypervisor pass-through, the memory scalability and memory capacity, the reality of UCS is that you can scale to at least your current workload requirements in terms of number of VMs and performance, generally with a smaller set of hardware from a UCS perspective. So it's all those technologies that we've built in, that we've surrounded those industry standard components with, that allow us to be the industry's lowest latency, best performing server solution. Okay. Last but not least, I cannot forget about centralized management. Right? It's one of the key reasons we have had the success that we've had. And again, in just 3 years of availability, we became the #2 blade vendor for new blade sales. And in just about 5 years of product availability, we became the #1 vendor for new blade sales. And quite frankly, UCS Manager is a huge, huge reason for the product success that we've had. So an absolute tremendous R&D undertaking. And again, we did that by listening to our customers. Right? It was all about what our customers needed in the data center. One of those requirements, of course, was true centralized management. Beyond just read-only view of the current state of things, it's true server management. And UCS Manager, it's your one-stop shop for all things chassis, server, and northbound connectivity related, as well as the configuration of each and every blade and optionally rack mount servers in your environment. Okay, it's a fully open solution, so it has northbound API availability for integrating with other technologies, and there's a lot of native integration today with various Microsoft apps, with SolarWinds, with vCenter. So there's a tremendous integration story with our ecosystem partners in the data center management space. The feature that gets the most attention, generally referred to as hardware state abstraction, formerly referred to as service profiles. This is a feature that a lot of our competitors are just now 5+ years into UCS's lifespan. They're just now starting to try to copy us. But this is basically the feature that allows you to configure per application templates. And inside of that template is everything you see here and a lot more. right? This is just a subset of the items that one would have to configure from scratch, whether you're configuring a blade or a rack, right? Before you can deploy a hypervisor or a bare metal OS, you have to give that thing an identity. That server needs UUID info. It might need firmware updates. It needs BIOS settings, MAC address, IP address, storage information, right? There's just myriad variables that have to be configured. And the average response in the industry for how long it takes to configure a server manually from scratch is absolute best case is 2 hours. Worst case is about a business day, a full business day. But the average response time, or the average amount of time required to configure a server from scratch, is about 4 hours, right? I have customers that configure 6 new servers a year, and for them it's a very, I'll call it a complicated process because they don't do it very often, right? It's not common knowledge and very a very speedy process for them. I have customers that configure a new server per week. And in that environment, obviously, there'll be tremendous time savings because of the number of servers that they have to maintain or have to configure. So whether you configure 6 a year or 1 per week, the benefits are still there, right? For the customers that don't configure servers a lot, it's a very error-prone process, and customers tend to revisit, right? If I don't configure this process or use a server config process all the time, outside of UCS, it's something that probably is going to take a lot longer than a couple hours. But anyway, what we do, again, is we take all that information and we build it into a service profile. Okay, that service profile represents a single server in your environment. We, of course, have a template function. So if every VMware server I'm going to deploy in my environment has these same 20 things in common or 10 things in common, I can create a single reusable template for all of my VMware servers that I'll ever need. And in this example, let's say it's a template for a database server. I log into UCS Manager, right? And I find my database template, and I tell UCS Manager, you know what? I just bought 4 new blades. They're going to be database blades. Go ahead and spin these 4 new blades up as a database server. Okay? Through the GUI, you can actually watch it, configure these blades. With the service profile function, it becomes about a 6 to 8 minute process to completely configure a server from scratch. Right? There are optional things you can do. Right? There's some security functionality built in from a data privacy perspective. You can tell or have that process wipe the hard drives, wipe the SD cards, and completely wipe the BIOS settings as well. So if you were removing a service profile, maybe you want to wipe the hard drives completely and reformat the SD cards. BIOS settings, I don't see a lot of interest there from a security requirements perspective, but certainly to be able to wipe those settings from scratch and start anew is valuable to a lot of customers. So again, what we do here with these service profiles, they're forever reusable in your environment, and it gives you consistent, predictable, error-free configuration of both your blade and your rack mount servers. Okay? All done through a single GUI. Equally important, and I've actually had customers point this out time and time again, because all of my customers have a server reuse policy. It's rare that a server that's 3 years old, even though it might be refreshed, it's probably not going to get thrown out. Right? They generally get repurposed in some fashion, even if it's in test dev or a QA environment. Servers tend to stick around longer than 3 years, even if they're taken out of one capacity and used in another capacity. So equally important to that initial configuration is the ability, because we have a UUID, right? We have identity tied to this profile. It's not tied to a specific server. It's part of that single profile. I purchased a new high-end blade with the latest processors, more memory for my database app, right? Once I back up my data, I can actually migrate that identity to that brand new blade. And that prior blade, maybe it gets a service profile that says customer name _ test dev. Right? So it becomes a blade in my test dev environment. And with that, it will have all the variables, right? The virtual MAC addresses, storage information, boot policy. It will have all those variables associated with my test dev environment. Okay. Certainly, because UCS is bringing together network, server connectivity and the servers themselves and storage connectivity and the hypervisor. It has very, very extensive role-based access control, or RBAC. So you can define as many roles as you need for your organization. Right? You could have everyone be an admin. You could have everyone with a siloed list of privileges. So network team logs in. Guess what? Network team will give you read-only views to the storage and the server pieces, but you have read-write capabilities for the network aspects. Right? Likewise for server, likewise for storage. There's operational roles. Yeah, you can create as many roles as you need, again, to map to your specific organization. Everybody's favorite server topic, firmware management. Feedback from my customers is pretty entertaining because you rarely get any kind of positive reaction when you start talking firmware outside of UCS, more specifically firmware updates. So generally it's met with creaks and groans and shoulder sags. It's just not a fun operational activity outside of UCS. So we tackled this as well inside of UCS Manager. It's the ability to rapidly and consistently deploy firmware and firmware updates. So it's a drastically simplified option or simplified process rather. You download the desired bundle from Cisco.com. It's either going to be an infrastructure bundle if you're updating the fabric interconnects and the I/O modules. It's going to be a B bundle for blades or a C bundle for rack mount. You download one or more of those bundles, and through the GUI, you actually program the updates. Now, one other thing that's not part of this presentation, but I've documented it in a separate UCS features presentation, is the ability to tie your maintenance windows into these operational processes. So whether we're assigning a service profile to a blade or doing a firmware update, you can define your explicit either one-time or recurring maintenance windows, and changes that you want to deploy inside of UCS will only take place when your maintenance window hits. So a very, I'll call it a simple feature, but a very, very powerful feature from an operations perspective. Excuse me. A few more slides here to round out the UCS management portfolio. So we've been talking strictly UCS Manager. A lot of our customers are now deploying UCS in a second or perhaps even a tertiary location. Again, UCS Manager is for a single domain. And so if you deploy 2 fabric interconnects in 2 separate sites, then you have 2 instances or 2 domains of UCS and 2 instances of UCS Manager. If you want to centralize that and manage all that from a single GUI, we offer to our customers for free UCS Central. And the software is free for up to 5 data centers. There is a tax support fee, right, which I would certainly encourage from a support perspective, but the application is free for complete centralized management of up to 5 data centers. So that's centralized service profiles, centralized policies, centralized firmware management, right? Tremendous amount of power in being able to oversee your entire enterprise server infrastructure from one single GUI. Above and beyond that, really outside of the management realm, right, it falls under the data center automation and orchestration category. We have UCS Director. Okay, so talk a little bit about that. UCS Central we spoke about. UCS Director is more than just a manager of managers, right? It allows customers to implement workflows, which are definitions of repeatable processes in your environment. So every one of my customers has a process they go through when they deploy a new VM or deploy a new server or need to provision more storage or provision more VLANs in the network environment, right? So the job of UCS Director is to it allows you to define those workflows. Every time I deploy a VM in my environment, what are the 6 things I do on my server infrastructure? What are the repeatable steps in my SAN and my network and my hypervisor? You define those workflows inside of UCS Director, and that becomes your single point of control, and you can actually produce a catalog for your customers, right? So the folks that you support at your respective organizations, you can deliver to them a catalog of services, right? Maybe you want somebody in the finance department, maybe a bad example, but marketing department, whatever it happens to be, you want that person or someone in that department to be able to request a single VM for test dev of a new application, for example. Right? So you can deliver to those users a catalog of services. For them, it's a beautiful, simple GUI, right? One click, provide a justification, an administrator can approve it. Once that approval happens, those workflows that you've defined then take effect. So UCS Director will communicate to UCS Manager and vCenter or whatever your hypervisor manager happens to be. It'll communicate to your Nexus and Catalyst switches and Cisco firewalls and on, right? So its job is to tell those other GUIs what to do. So in and of themselves, those other GUIs are great applications, vCenter, UCS Manager, et cetera. But now you have a solution that can oversee all of them. Right, so that's our single pane of glass for data center automation. And I do want to save a few minutes here for Q&A. So last slide, again, no surprise, we entered a very, very mature server market when we released UCS over 5 years ago. We've had a tremendous success record, right? Tremendous track record here of market share and delivering that next-gen solution that our customers have asked for. And again, because we entered that mature market, you can expect the full gamut of services associated with your Cisco compute offering. Everything from basic warranty support all the way up to 2-hour response, on-site assistance, and everything in between. Right? And we do have a feature called Smart Call Home, which I did not touch on earlier. It's highlighted in the sixth item down here. But as you might guess, this is a feature we offer on several different UCS or data center product lines. And it allows you to collect forensics and ship that off to the TAC automatically should an event of a particular severity occur in that particular environment. So it's a great way to proactively create a support call or support ticket, if you will, a service request, and get some proactive analysis on that, especially if it occurs after hours, for example. And these will definitely send out. I put together a nice list, and we've mentioned several of these along the way here. Things like Performance Manager, the Power Calculator. There is a free VM for UCS Emulator if you want to get some hands-on and exposure to UCS Manager. The App Sizer I did not mention. This is actually a webified tool now. It does require a very specific level of access to CCO, but for the 5 apps you see here, we can punch in the specifics for your environment, for your exact application requirements, whether it's transactions per second, IOPS, what have you, number of mailboxes. All these applications have various sizing metrics associated with them. But we can punch in the specifics for your environment, and this particular tool will produce a recommended UCS configuration. And then some additional links here. The test drive site is a kind of a one-stop shop for all things UCS. The interactive model is interesting. We have this for all of our data center solutions and non-data center solutions, but it's actually a 3D product tour that you can pull things apart, put them back together, shows you all the bits and pieces and how the solutions fit together. It's a pretty slick tool. And in 59.5 minutes, we've covered all the slides.
All right, thank you, Joe. Great presentation. I actually have a question from one of our, thank you. I actually have a question from one of our attendees, if you wouldn't mind.
Please.
Interconnect switch airflow is front to rear. Where is the exhaust vent?
Also on the rear, right? So front to back airflow is rear exhaust, right? So you'll find that on the fabric interconnects and the chassis. If that answers your question, right?
Yeah. That's the only question we really had, so I think we're set now.
Okay.
I hope
that's a critical, 3 simple things with data center solutions, and I discuss it with every partner account manager and Cisco account manager and anyone touching the data center, right? There's 3 things that matter above and beyond just defining the requirements. It's the requirements of the solution itself, right? It's the power cords that are required, right? You have modular power cord. So is it going into a PDU? Is it going into, or what type of PDU is it going into? Is it going into a wall outlet, right? So the power cords are critical, the right transceivers for all the physical connectivity, and then the airflow related to that particular question. right? Depending where solutions are going, you need to know hot aisle, cold aisle design, front to back airflow, very, very different, of course, from back to front. So front to back to front options, right? Those three things are critical to understand in every data center.
I have another question that just came in. Will these devices go into a standard rack, or do you need a Cisco rack?
Nope, 4-post rack are required, but it does not have to be a Cisco rack.
Okay, great. That's all the questions I see for now, so I think we're set. Before we go, though, I'd just like to remind everyone that we'll post an archived version of this presentation on our website in the next few days. Just go to terakai.com/webinars to view it. Joe, thanks again for the presentation. Really good stuff. And
My pleasure. Thank you, everybody, for your time this afternoon.
Awesome. Yeah, thanks, everyone, for attending the webinar today. We look forward to talking with you again soon. Have a great day.